The Department of Mechanical Engineering at Northwestern University's McCormick School of Engineering is a leader in fundamental and applied research to develop breakthrough technology and energy-efficient systems for a sustainable world.
The areas that we cover in mechanical engineering include traditional areas like solid mechanics, fluid dynamics, and more recent or emerging areas such as robotics. And we're growing into areas of nanotechnology and biology and bio-inspiration.
The field of mechanical engineering requires a lot of creativity. We come up with devices or modify something with a creative solution, and all that takes the ability to think of something that's never been done before.
Research is conducted in 6 principal overlapping areas. Design is a thread that runs through all of mechanical engineering. This video will highlight only a few of the many research projects currently underway in the department.
How is the nanocomposite sample coming?
Nanoscience and Engineering focuses on the modeling and experimentation of novel materials and devices. Kate Brinson's research team is investigating the effects of infusing nanoparticles into polymers.
Very tiny amounts, 1% or less of nanoparticles, can dramatically transform the properties of these polymers. The advent of both computational power and experimental tools to see at these small length scales and to calculate things at these small length scales has opened up all areas of mechanical engineering to fascinating new research.
Other faculty student teams are researching energy conversions using nanophotonic devices and next-generation electronics.
So you're controlling 6 degrees of freedom of motion of this plate based on accelerometer feedback.
Right.
Research in the area of robotics includes automatic control and the construction of robotic devices.
How robots can move an object from one place to another under computer control, trying to use vibratory motion without ever having to grasp any one of them.
New initiatives in human interface engineering involve collaboration with the Rehabilitation Institute of Chicago. Biological and bio-inspired engineering explores the close relationship between mechanical engineering and biological systems. Cheng Liu studies the hair cells of spiders, which are highly sensitive flow detectors.
We're building man-made version of flow sensors based on the spider hair, and actually I would say that we actually have the world's best flow sensors. We actually follow a pathway from basic scientific discovery to innovative engineering. For example, we are applying the flow sensors to IV instruments. We might be able to build a cheaper and more portable version of the IV instrument.
Manufacturing, tribology, and energy integrates design with a deep understanding of material mechanics and manufacturing processes. The goal is to minimize energy consumption in the design and manufacturing of products worldwide.
I would like to work on a lot of green technology and to just do a lot of social design for more responsible living.
Mechanics and materials research aims to understand the behavior of materials and achieve superior performance from materials and structures. From the atomic to the macro scale, multi-scale system design and optimization covers state-of-the-art theory and techniques for modeling, simulation, and design of complex engineering systems.
The next time when we do this, we may or may not use transistors.
Undergraduates receive a fundamental education in math, physics, and chemistry, progress to solid and fluid mechanics and thermodynamics, then move on to design and engineering, heat transfer, robotics, and control. Students design and eventually build their own devices. The Mechatronics Lab allows students to rapidly prototype electromechanical systems, and opportunities to express creativity extend beyond the labs.
They could compete in the annual robot design competition. They can help build a solar-powered car. They can participate in the robotics club. They can work on the Formula SAE race car.
The primary focus of the graduate program is to help students discover new technologies through experimentation and cutting-edge research. The top-ranked undergraduate and graduate programs prepare students for careers in industry, government, research, and academia.
They're in every field imaginable. from aerospace to nanotechnology to the legal fields to government labs to working in DC on policy matters to consulting firms. Our graduates are really everywhere.
Anything that moves, anything that is designed, pretty much anything you can dream of, it takes a mechanical engineer to build part of it.
In the mechanical engineering department, world-renowned professors teach small classes and invite students to join them in groundbreaking research.
But we are interested in producing students who are curious, who can ask questions, before other people ask them. And if you ask questions before other people ask them, most likely you'll have an answer before other people have an answer. And that will turn into tremendous advantages for your life.